Good morning, everybody. Good morning. Good morning. Up on the board, you have your class load once again for Google Classroom. I'm going to give you about 30 seconds to make sure you've done that. Then we'll move on to our review now today. We are switching Google Classroom away from Schoology because of the Schoology issues that we're having, which is a fun time. So take about 15-20 seconds to finish that up. The only thing that is in Google Classroom that you'll see is one assignment. We're going to work on that assignment towards the back half of the class. It's the main thing we're going to be focused on today. We are going to briefly discuss your do now. Okay. Log into Google Classroom, that's the chat code. I'm going to write the class code up on the board, and then I'll put your do now up. While I do that, I want you to take a look at this. I'm going to read the first part of this. We're dealing with a squirrel population. This is a hypothetical analysis from 2015 to 2020. Some scientists estimate that the number of squirrels in the population is 150% more than the number of squirrels in the population at the end of the previous year. See how this relates to what we're actually doing? It's nice to have a do now that does. The model estimated that at the end of 2016, there were 180 squirrels in the population. So which of the following equation represent this model, where n is the estimated number of squirrels in the population t years after the end of 2015, and t is less than or equal to 5. Take a moment to think about it while I take a hint. I'm sure you guys can do this answer pretty good. Can you please?
Cameron, if y'all gonna call on me.
Hey, you saw that first one in there, you was too excited. Cameron, do you want to think about the do now?
It's okay, she eating.
I'm sorry.
Oh,
I'm not sure why. Darian, Nadine is not here, Cameron's not here. Naya. Shania is not here, neither is Michaela, but Kaylin is. Jaden Larkin is here, Khalil is not. Dion, I don't see him. Here. 5 years. Paige not here, Janila is, however. Valeria is not here, Kayla is hiding. Armand's not here, Armandia is. Tyler is not, another she. Raise your hand if you have an answer to the do now for me. Right. Janila, can you tell us the answer? Janila, can you give me the do now? Yeah. Raise your hand if you disagree. Hey. So, what is n here? Someone remind me. The number of squirrels, right? Now, if I'm doing n here, now what's my t?
Testosterone.
What's t? Years. Number of years, right? Now this is an exponent. So, if it's been 2 years, then what would I do here with this exponent? Yeah, I would do 2. True. But what would I be multiplying? 1.5 times, right? What would that give me?
2 1.
What do we think? 1.5 times 1.5. Not 3. It is 2.25 because half of 1.5 is 6.7. So add that to it. Now, If I take 2.25 and I multiply by 180, what would that give me? You know, at the end of 2016, there are 108 schools in the completion. So, is that what we would expect to have happen? We start with 180, and we end up multiplying that by. Does that make sense? So, Jaden, what's your argument for it being this?
Oh, that's fine.
Okay. Well, 72. What's the significance of this 72 here?
I think it's like, if you multiply it by, never mind.
So you want to go with C? Well, now we're all on the same page, and C is in fact the answer. Can I do that? Now, I want to start out because last week we had finals. This week we've had 3 days off. And the week before that, we studied for finals from Wednesday and Thursday and Friday. Then Monday and Tuesday, that week, the week before last, we did lesson 4. The last time before that we have actually done lessons in this class was before Christmas break. It's been a hot minute. So I want to take this opportunity to just recap for us what we've done so far. I want you to turn to a partner and I want you to ask them everything they remember about zombie fires so far. Everything about and zombie fires.
Oh, that's wrong. This one's
Tree, water, that one.
blind.
Yeah, it'll be in a dark and then you can be careful, try to, you may be. It would check back on a year later, that's about. No, we haven't got such a.
Raise your hand if you can tell me one thing about zombie fires. Taylor? Big things. Why do we call it a zombie fire? It goes out, then a year later it comes back and it catches back on fire in the same place. Do we remember anything else about zombie fires?
They're starting cold.
They can start in cold weather. Take a look at some of these models that I put up back here. You guys made these models way back when we started Unit 2. And I need to put more pins in because students keep taking the pins out of my models and it makes me angry. And then the last one I have to put in staples. I hate staples. You know, just remove staples. A butter knife? I mean, I could, but it's still a lot of work. And I always end up getting pierced by staples. Nevertheless, what's one more thing we know about zombie fires? It starts with cold. It comes back to you later. What else?
Most zombie fires start with peat.
Heat. That's our big thing. We dealt with that in lesson 2 and in lesson 3. Can someone remind me what peat is? Someone I haven't heard from yet. Dead organisms, true. Do you know what kinds of organisms, Cameron? Plants, absolutely. Dead ancient plants, right? Perfect. So we have these zombie fires going on. We know that they start with peat. We know that they start because of peat that catches back on fire. What's the significance of peat? Why is peat involved here? We dealt with this in our first experiment. I showed you a video of it. Cameron?
Because it's under the snow.
It is underneath the snow, it's underneath the permafrost, right? There's something else about peat that's really significant. Jalen? It takes a long time to burn. Absolutely. And it can burn even underneath the snow. Those are two things about peat that are really significant. It takes a very long time to burn. So that's why a year later it can restart because in reality it's still burning under the permafrost. And then it just catches back on fire. Alright, now We also did another experiment in lesson 3. What was the other experiment that we've done so far? Someone I haven't heard from yet, probably. Marcia?
The yeast experiment.
Thank you, Marcia, who raised her hand. What did we learn about in the yeast experiment? Darian, do you remember?
Nope.
No, you don't remember the yeast experiment. Well, Jaden explains that to you. What did you learn about in the yeast experiment? Remind Darian for me.
All the different temperatures and efficiency in there. All the different temperatures that they
Yeah. Like the yeast. And what? Yeast. Jaden, can you tell us?
What the workplaces were.
It wasn't replacing organism. We were using it to model. Remember the sugar that we added, not glucose. But there's something else that it modeled. Kayla. It did not model. It produced carbon dioxide, but that was why we were using the yeast.
Oh, because it's extended. It was
True. No, that's not what I'm looking for yet. What kind of organism is yeast?
Abiotic.
It is a living organism. It's not abiotic. It's abiotic, it's not right? It is biotic because it's alive. But what kind of organism is yeast? We have herbivores or carnivores or
a decomposed.
decomposers. There we go. We got it. It's not for everybody. Decomposers. Kind of decomposer. And so when we did that experiment, we had our yeast in cold water and warm water and hot water, so that just like we said, we could model how temperature affects decomposition. That was our main goal for lesson 3. And so someone remind me, how does temperature affect the decomposition? Jalen's on fire today.
If it's hot, it will react quickly. If it's warm, it will react slowly. If it's cold, it will react at all.
Precisely. Nicely said. That's what our experiment revealed to us. In lesson 4, we started talking about photosynthesis. And you guys were tested on this extensively on your final. Hint. That was the best set of questions in terms of your guys' average. More of you guys got the photosynthesis questions right than any other section. So, good. But we'll talk about your final exam a little bit later because you weren't the only one. Yes, but not.
Miss Mapel, I'm really wondering government heading. I think I'm
Talking about the final exam, let me talk about how providing that you it didn't go the way I hoped it would. So that's far. If you can hear me, clap one. If you can hear me, clap twice. What happens if I can't get our attention after I attack and clap twice? Thank you, Kaylin.
In the cold.
We go outside of my classroom and we have the whole experience that would be a not fun time. So thank you for your attention. I appreciate it. So that's what we know so far about zombie fuels and about energy and matter in ecosystems. Remember, that's our main topic for this unit: energy and matter in ecosystems. What do we still not know? You think of anything that we don't know about what?
Fireflies.
About zombie fires, about photosynthesis, about how ecosystems work, matter and energy in ecosystems.
I got one going.
Okay. Is it serious?
Yeah.
Got
We
it.
need to know how we can turn heat into an energy source instead of fossil fuels.
Well, we actually know that. You said it on the line. And then it said, just like photosynthesis. Alright, well, a bit about what we still need to know. I still have questions about photosynthesis. I still have questions about how there are 1.5 million metric tons of heat under the permafrost in the Arctic. Because that is a ridiculous quantity of heat. Do you remember that from our reading? That's a ridiculous quantity of heat in the coldest place on Earth. I get it. There was more sunlight in the past, but only by like 2 degrees more. The tilt of the Earth. Remember reading about that in geologic times?
Yeah.
The tilt of the Earth in the past was only 24.5 degrees, and now it's 22.1. The difference in those 2.5 degrees is having a forest in the Arctic versus having glaciers and just straight ice in the Arctic. That's crazy to me, isn't it?
That's for real.
That's crazy. I still have questions about how that's possible. I also have questions related to your guys' exit ticket in lesson 4. You saw these these maps where we were looking at, well, what is this map of? That is a map of the continents, that's true, this is a map of the Earth, and so is this one. What's the significance of this?
Heat, solar radiation.
There we go, solar radiation, perfect. Kaylin, what's the significance of this map? This is solar radiation. What's this?
Water.
Kaylin? Do you remember?
Oh, gee, listen. Where is that? Be home.
I'm so excited.
I don't recall.
Anyone? Triathlon who's waiting? Yes.
Jigger.
Okay.
What was the question?
What is the significance of this map? This one is solar radiation.
Oh, that one, sugar.
That one is sugar. That's sugar production, glucose production. Both primary products. This shows you where we're producing more or less sugar on the Earth. And we compared this map to this one, which is showing us how much energy from sunlight we are getting in given regions. That's where we are so far. Now, we're dealing with photosynthesis and how sunlight affects it. We're still on that, but we're going to do an experiment in lesson 5 as well. So this will be our 3rd experiment so far this unit. Which experiment's my favorite part, I don't know about you.
I like spirit.
So before we get into our experiment for the day, let's talk about the directional hypothesis. What's a hypothesis in science?
An educated guess.
Basically, an educated guess. That's at least what we tell you in middle school. It's a little bit more complicated than that. But I'm not going to get into advanced scientific terminology here. An educated guess works just fine. We are going to guess. Generally speaking, yes. That's a great way form to put the question in. When you read scientific literature, you'll learn about p-values, which deals with the probability of null hypothesis. There's a null hypothesis, which is the opposite of our whole complicated math. I'll teach it to you by the end of this lecture. We're going to talk about directional hypotheses today. If a hypothesis is an educated guess as an answer to a question, what do we think a directional hypothesis might be? Someone other than Armantia, who is currently our rockstar student. Jalen? It looked like I'm still gonna study the red green. What did I want? Not. Let's take a look. Yeah. A statement instead of a question. Nice to add context clues as well, but not quite what we're looking for. We talked about positive and negative relationships earlier in the class, way back in semester 1. Now we're going to talk about combining those relationships between two things into a hypothesis in the form of a directional hypothesis. The directional hypothesis tells us not only what we think will happen, but also the kind of relationship we expect to have. We have 2 of them, direct relationships and inverse relationships. And this is very similar to our positive and negative relationships that we talked about earlier in the semester. A direct relationship, think of it like a positive relationship. This says we expect as one thing goes up, so will the other. The amount of one that we have is determined by the amount of the other. Our dependent variable goes up if our independent variable does. The inverse relationship is the opposite. As our independent variable goes down, our dependent variable will go up. Those are two options when we make a directional hypothesis. Here, we're going to talk about the relationship between the available sunlight and the amount of glucose that plants can make, how much carbon plants can store through photosynthesis. So, someone raise your hand and give me a hypothesis about whether this will give us a direct or inverse relationship.
Inverse.
Inverse. So if I have more sunlight,
Yeah.
I'll have less photosynthesis.
Let.
Interesting. Why do you say that?
It was a 50-50 chance I take it.
No, I appreciate the honesty. Will anyone else have any reasons for that one, or maybe a different answer? Kayla?
Available sunlight, it was available for more advanced, so
Absolutely. That's my directional hypothesis, and we're going to try to prove that in our experiment. The more sunlight we have, the more glucose we can produce, the more photosynthesis we can undergo. We're going to do an experiment. I haven't talked to you about what this experiment will look like yet, but if we're trying to prove this hypothesis, the more sunlight we have, the more photosynthesis we'll have. If we're trying to prove that, give me some ideas about what we could do in order to test this hypothesis. Take a moment to turn and talk to a partner and see if you can't come up with an idea. It is so quiet in here. That's because we have almost nobody in this class. Literally, my attendance is less than half today. It's crazy.
I mean,
It's not. But I do want you to turn and talk to a partner about how we can test this. How can we compare how sunlight affects photosynthesis? Start. Okay. How much sunlight?
Sunlight.
Feel like more sleep.
Give plants energy and everything that get they use like glucose, right?
Okay.
Right.
Sure, we tilt it.
And then they use the glucose the other stuff. And then carbon dioxide for the plants.
So how can we take a look and compare the amount of how the amount of swim distance?
What's up?
You got any ideas? You have any ideas? Not. If you can hear me, clap. If you can hear me, clap twice. Thank you for your attention. So, raise your hand if you have an idea of how we can test this. All right, eeny, miny, mo, Janaya.
also, we have a thing that I've used in my first tournament. They always put a ceiling to the club with the work. One is like darkness, and you like see how they were.
To me, this just ran very similar research, right? But and make it a little bit more scientific. How can we add to that experiment? And I'm just gonna have a little hint here.
So that
You don't remember?
that juice. Alright.
What is something one?
It is bromothymol blue, ETB.
Yeah. Yeah.
Yeah. And just remember what BTB does.
It's yeah.
Okay, raise your hand because you're all talking at once. Jaden. I have to inundate at this point. You're also doing so well. I appreciate your enthusiasm. Yes.
doesn't like figure out how much carbon dioxide something produces. What's wrong with it?
It does measure carbon dioxide. Do you remember how it does that? Jade.
It changes to yellow.
It does. It's yes.
For pH.
Yes, it measures pH. It's an indicator of pH. So when we add more acid, such as an example of this, carbon, yeah, it's carbon dioxide. When it dissolves water, it turns into acid. It's actually anhydrous carbon dioxide, but nevertheless, it becomes an acidic solution. This changes to what color? Yellow in an acid. So, why would I use this in this experiment? Thank you for raising your hand. Armantia?
To see how that carbon dioxide is.
Cheating.
No.
Do plants produce carbon dioxide? I mean, technically they actually do, but not nearly as much as they take out. So, how are we using this?
What is that?
Is taken, is consumed by the plants. Absolutely. Now, here's the question. This is bromothymol blue. Samir, what color is my bromothymol blue right now? Blackish, right? If I were to pour this out, you'd see it's kind of sort of bluish, dark blue, kind of black, right? So if right now it's blue, is it in an acid right now?
Yeah.
It's not. So if I want to measure how much carbon dioxide is taken out, what might I need to do with this before I start my experiment?
Well, they can
Oh yes, put it in a container, that's true.
make it yellow.
Yes, how do I make it yellow? Such as?
color no.
Absolutely. How can I add carbon dioxide to it?
Green.
Yeah, that's exactly what I'm thinking. That's exactly. I'm gonna add it into your touch sheet, and I'm gonna take a straw and I'm gonna blow bubbles. No. Because all I need is one student to decide.
To drink it? Yeah.
And I would lose my temper. We do not, under any circumstances, at any point, we will never consume anything in Miss Mapel's classroom. It's the fastest way to get kicked out of my class and become my new least favorite student. I like to be miserable. That's part of this investigation. That's part of what we're doing. What about this sunlight component? We've talked about the BTD. How do we use sunlight in this?
So, what's in the box?
What do you think is in the mouth?
Yeah.
Do you think so?
Yes, bro.
You think so too?
Yeah.
It's better. It's worse. Yeah. Well.
What is it?
It's a lemon.
You are right. It is a lamp. This is a solar lamp. Why would I want to use it?
Because there's no sun. It's cold.
It is frigidly cold. Why are we here? Yes, that is precisely it. It is frigidly cold. It is snowy. There is no sun. The world is deep in which we are here, and I am your ray of sunshine today. So, how can we use our solar lamp in this experiment?
One
Jalen?
is the lamp.
Jaden, we need to. Can you identify your hands to me? You don't. Are you sure? You might need to take my anatomy and physiology class.
Yeah, I don't have how much of me.
Jalen, what is this? Which was?
One of which I didn't let it was fall away.
Okay, absolutely. I'll put one better because you're basically right. We're gonna have 3 plants. One of them will be directly lamp. One of them will be the lamp will be an angle away from them, indirect light, and then what? Take a look how Earth tilts gave us more sunlight and how that contributed to there being a band. And I cannot stress this enough. 1.5 million metric tons. That is 1.5 billion pounds of peat in the Arctic, where it was frigidly cold. That is more peat, there's more carbon in that peat than there is in the atmosphere. There is more carbon dioxide trapped in that peat than all of the fossil fuels humanity has ever burned. That is crazy. So do you see why this is important? And there's some people out there burning it. Just for fun.
In the space.
No. That would be, the amount of energy it would take us to do that would have to be more than the piece for your, yeah. So, that's our experiment. You're gonna take 3 plants, this is what it looks like. These are our plants, these are your reagents. What is in the cup with the bluish stuff?
The water, the BTB.
Yeah, what are these? Yes, absolutely. Do you think I have test tubes with lids?
No.
No, I do not. However, I do have test tubes that do not have lids. So when I was starting this experiment for the longest time, I was like, oh, it's okay, I have test tubes. I sat up in bed last night at 2 a.m. and I said, my test tubes don't have lids. So I'm gonna get plastic wrap. Oh. And we're gonna jerry-rig it up, and that's okay. Do you know what I'm trying to... What's this?
She said.
Plants. What kind of plant do you think it is? Farmer. You are incorrect, but close actually. They're all related.
Don't invite anybody.
Here's a question, bro. PCB, right? It does a solid liquid or mix. If I want to measure how much carbon dioxide is being taken out of this solution, could I just use a tree?
Yes.
No, because that wouldn't be in the solution then, right?
Yeah.
What kind of plant could I grow in a solution of water? Seaweed.
Algae.
This is Elodiad, also known as seaweed.
Oh. This stuff right now.
That is a seaweed.
Seaweed, what else?
Wait, you consume seaweed?
Dry seaweed.
I'm in a winter.
You feel yeah.
Oh! Food that I don't consume, got it.
Just like me.
When you shop with sushi,
Like twice in my life, it was delicious, all of it, but you not have seaweed. Do you have a lot? Give me my mouth. This is what your experiment will look like. However, we do still have some planning to do. We've talked about a lot of this, but you need to know what our independent variables are, what our dependent variables are. What controlling for? Can someone define for me what a controlled variable? You guys are competing, ain't you? Alright, come on to you.
something that doesn't change.
Exactly. Something that we're controlling for to keep constant in our experiment. Absolutely. In this experiment, what kinds of things might I want to keep constant?
The amount of
For all three. Is that something I'm controlling?
The
No.
the BTB.
The BTB, right? What about the BTB? Right? Okay. Interesting. What do you think? The color? The color? Should the color stay the same for all three throughout the whole experiment? What should about the BTB?
How much?
Yes! There we go. How much BTB we add in the beginning? How much BTB do we add?
Yes, I mean, part of her page.
How much BTB we add is something we're controlling for. We want to make sure all three plants have the same amount of BTB. I also want to make sure all three plants have the same length. Absolutely. How big is the plant? What else? What do you think?
Because they have different techniques, routes and how much of it does it have, but they're all different.
Now, this is just the angle of the camera. They look a little bit different, but these are all the same plants. They're all roughly the same length. So we're not here to like pull out like millimeter measuring sticks to make sure they're exactly correct, but they're roughly the same length. We don't have one that's long and another that's only an inch, right? What else are we keeping constant?
The test is.
Yes, the test tubes. That's a clever one, actually. I didn't even think of that. The test tubes. We want to make sure they all have the same test tube. right? Because if one has a big wide test tube and the other has a very skinny test tube, you know, how will it be affected, but it could, right? It might and so forth. What keep all three of them in yes.
I have like an interest of how it can change. Like if it's too big, then you might put a little too much BTB in it and it might run you.
That might.
If it's too skinny, then you might put a little, like too little, and it won't like work properly.
Absolutely. We wanna keep all three of them in the same room. Because I want to make sure they're all the same temperature, absolutely. We don't want one to be in the fridge at cold and one to be in a sauna. Yes,
The amount of time that you guys get.
perfect. That's my next thing I wrote down. You stole it directly from me. How long we run the experiment for? How long the plants are used to? We also need to make sure that all three of them are more or less the same level. Like we don't want any sickly, like yellowish kind of frumpy seaweed in here because that might affect our experiment. Which is why I have not yet the Olivia, because I do not want it to sit out for an entire weekend, because I want it to be somewhat healthy. Somewhat, we're gonna do our best. Those are things we're gonna control for. What's our independent variable?
The lamp,
The sunlight. The sunlight, that's the thing manipulating, right? It's not gonna stay the same for all three plants. And we're gonna see how our independent variable, the amount of sunlight, affects our dependent variable, which is the amount of carbon dioxide that we consume. Perfect. You guys are gonna have to question about all of those things, so I hope you were paying attention because we just basically gave you the answers. I get into the classroom, you have precisely one assignment, because I'm still working on how to make little classroom work because I've never used it before. So, I'm an investigation. This is not actually the system that I use. Yes. We'll also be keeping track on my Flipboard to make sure that you are on track, that you're understanding the things. If you have questions, please don't hesitate to ask. I'm going to give you 10 minutes on this first timer. Sorry, I'm going to give you 4 minutes on this first timer. By the end of this 4 minutes, you should be finished reading through all of part 1, which just talked about the investigation plan. You can work with a partner to partner read on this section if you would like, but I want you to be all the way through this. Once you finish reading it, I'm going to turn and talk to a partner about it. By the end of this 4-minute period, you should be fully finished reading through and talking about it, and then you can move on if you're all the way done. Which I'll give you 10 minutes for. Do you have any questions for me? How much time do you have for reading through part 1? 4 minutes. 4 minutes, that's right. Yes, 4 minutes starting now. I will come out and make sure that you are actively engaged on this.
Your teacher is cool.
materials that.
You don't need to send me. Should be have new children. On dairy.
Control is us, you have to be this, and then work. So it's about.
Yeah, and see you later.
Thank you so much. You question? Offering, perfect. Works Lisa. So I'm gonna finish reading the once you finish reading it, and I'm gonna do about it. Feel about it? I see. Yeah, fine. Do you have any questions about this? That's fine. If you're finished reading the course, then why did I you about it? How you doing, say this? I'm waiting for this call. How about? I gave you the option with partner ratings. Want to do that?
Okay, what's the difference in the location?
Good.
I think that if I look at you, even seems like the right. Well, that kind of shows.
Jaden. So I have 200 Jadens. And then a Janaya, which is both. Yeah, Janaya. Okay. Let me see that you're answering question one. Or these have started question one. Sure you know. How the amount of food the friends after some reasons more than this only. So complicated and virgin or because of that manipulating your we want to see how much you Now to the life to find some like the baby was hard in that that was for if you can hear me that way, not finished part one.
Yeah, okay.
Now, first, roughly 10 minutes for the second part of our topic, the first four questions in part two. Now, question, but I want to make sure you're working with your partners. One thing you should know, we will, when we start this experiment on Monday, Tuesday for you guys, I'm going to have you in groups of between 4 and 5. Why am I going to have you in groups of 4? Per group, right?
What was the question? Sure.
Why am I having groups of 4 to 5? So you're not.
No. 4 and 5 is.
Yeah, limited resources.
We do have limited resources. Yeah, I have bad experience myself. So like I ain't breaking the bank for this. Also, I only have so much desk space. We're gonna put all the plants on that desk. And like that gets tricky to manage. So I don't wanna have 120 sets of food plants. That'd be a lot. I have 120 students, so I want to like minimize the amount of plants I have to keep alive. Alright, move on to your questions. I have 10 minutes. By the end of the 10-minute period, you should be through at least question 4. Work with partners about this. You all want to be on the same page. Yeah.
So we're trying to pursue, we gotta stop all the money, right? That's that one.
Do you have any questions for me? Oh, if you have to discuss it. So you restate it to me?
Hey, Kay, what you give for number 1?
That part of numbers. No, it's fun.
Okay, we're using BT on an experiment.
Yeah, I'll take that.
10 minutes.
Which goes this one.
So I want to do on this stuff. It says the more of this we have, the more wealth. The more sun, the more resources will do. Part of the take us into anti-corruption business and ensure workforce. So that's our directional hypothesis. We need to prove that if I add more sunlight, we can move more workforce.
That's the easiest part of the one.
Yeah.
Read it with your study.
Talk to me about how modeling a culture of these. Yeah.
You know, once you own it's Monty, you gotta get to work, man.
No. Please don't backseat teach for me.
No vaccine.
I've never heard the word text.
It's an interesting term. I made it also.
Maybe.
It's not like,
But it's this.
wait, what?
That place.
Where's the?
Unfortunately.
Your place is and the for the sixth step that you just read. No, okay, see, this is another. Six steps or one, like, nine. Yes, yes, I don't want to. Process everything, right? But you don't have.
More students. Yeah. I do. Putting your guys' program in a matches that you have, going to be engaging. So, do your work, or I'll have data that says that you don't, or your parents love to see it. If you don't work. So I don't read the program.
Are the
Pictures. We do all except for 9 and we have a shooting shit. This one we're halfway through that first intrusive. We set up a gas station. Do not build a wall for it, we just gonna show us that someone you should expense.
as, no, not super.
Three.
How?
Time for what they got.
Interesting.
So I'll skip to three because that comes out the easiest and the fastest to get down before I get to number two.
Wow.
How is that? It's eggs.
It's not all.
And
It's all happening.
there will not be. Yeah, Melanie.
Also, fast, now, and some of you about it, and it's in so that's in the email I sent out there.
My understanding, yes, so it should also be in January week here, so.
Oh, so that, I mean, we made
That's that, how long is this? We'll see how much time. See how the.
let's
Action, this is great.
59 here. I'm great hearing, so.
I don't have them all memorized. They made me grade 130 finals in 2 days. That was over 1,500 pages of grading. I have to have this. I together for 11 years.
Never did.
It was
It's not counting less.
I never reached those.
78%. You lost
Now, move on to our next question. What
I'm very stupid, I heard words.
okay, I have it's gonna be done. I'm so sorry they get sore.
We can do those.
I see nothing.
Well, no.
Let me ask the whole class to check. Raise your hand if you're confused about number 1.
Yeah.
Stupid about how.
Yeah.
Very good.
Let me check this on the board and we can take a chance yet. But this is like the 5th student who's asking about it. So why don't we take a look together? Here we go. So this is your question 1. Remember the directional hypothesis that we gave earlier. How will you manipulate your independent variable in step 6 to generate evidence to support or refute your hypothesis? let's define some terms here. What is my independent variable? So independent variable is the amount of light, right?
Yeah.
Now, when it says manipulating the amount of light, how am I manipulating it?
You're changing how much that's the link.
Yeah, like the lamp, like yes,
Yeah.
sure, yes. We are moving the location of our business to the red plants. Be either directly under the light, partially under the light, or in aluminum foil, so there's no light. That's how we can manipulate our independent variable, which is sunlight. Now, what's our directional hypothesis? Exactly. The more sunlight, the more populations it will be. That's our hypothesis. We need to prove that hypothesis by manipulating our independent variable to support or refute our hypothesis. How are we collecting our evidence? With the BPT. Guys, look at the color of our BTB. I said it right. That's the evidence we collect. So, what are we going to use?
What's the baby B?
BTB. It's in this. I need you to focus on light.
Jenny, give us water. Yeah.
Now, I think we should let's in the time because we're losing track of time. I'm gonna give you guys an extra 6 minutes, but by the end of that, do need to go on question.
Wow, yeah.
Like,
Show me your question once, so you can get your second one. You got a question? You can check out. I'm gonna do that. He's so nice. They're so cool. You don't even need a pencil for this, like, and you have one, right? Do your work.
Automatically to the.
What color should be at the start? Yellow. Yellow. What color should be at the end? For all three beakers, should it be blue?
No.
What color should it be for the one that be dark?
Yellow. So you.
I move it around one day, man. It changed color. No, when I moved it, changed color. It changed color.
I like the nonsense. Let me help you.
Yeah, or
Oh,
well, that's also back home.
I got this.
Talk about her dad. Carry on her ball.
Be like,
What are you saying, sir? It's sunshine. But then when they check the fund, they'll find, yeah, it's still, it's it. I see a control. I see that, I'm sure. Who was it? I don't know. Who's all us again? I don't know. And
This may hold what? We are doing my feelings. Sorry, I'm doing that. For now, she's very clean.
it's small.
Yeah, the mistake. We make a thing.
Huh. You're on the right track.
It's a hard.
Although, yeah. I heard maybe.
Oh, so fast. You didn't give me no time. Let's take it to be it.
What do you do? Yes, I agree on this. You have we have work to do. I gave you guys all of the answers on the board. Okay, we have about 25 minutes left of class.
Yeah,
You gotta get through this whole thing in that time.
This guy needs a little.
I,
all the ones. My careless.
next, and not, since you should be through freshman at this point, if you're only into one, you can do questions 6. Do you not think that's reasonable? Yeah?
Where?
Point, if you have questions, please raise your hand and I would be happy to help you.
You should.
So,
It's not bad.
I'm giving the rest of the gas to this. Not you were control. You remember controller. What was it in class? So the lights are in the air. We want that to be different from the questions.
we want our control variables to be the same. Yeah, sure. The lid is something you want to take on lid. The amount of BTB, have the lid open volatile. The amount of water that we're controlling for, the temperature of the moon, we want all of these things to be the same for all things.
And then also,
Find out, not more than.
I. Stress. Get up and see. You got she can listen to us over to. Never asked. Well, first, I like, no, That's why.
Yeah.
Well, the thing. Girl, no, I had one girl, she could, she was like, she had this thing, they got that.